What's up everybody, TooTallToby here, and in today's Onshape step-by-step tutorial, we're going to model a part that comes from the real world. This is a paper towel holder. You can see that there's a plastic cap that goes on the top. There's like a little kind of stepped area there at the top of this thing, and then you've got this plastic cap that fits on there. And I love the idea of modeling parts that come from the real world, because the more you practice modeling these parts, the more ready you're going to be when you actually have to model something like this in your engineering job. And so what we're going to do is we're going to obviously go through and do a sweep, and this will be a sweep using a 3D path, which is pretty cool. We're going to do this using a composite curve. But what we're also going to do is we're going to incorporate the use of a variable studio and a variable table. And these are so powerful in Onshape, and something that I think every user should get comfortable using, because what a variable studio lets you do is sit down with the customer. Then the customer might say, what would happen if we change this width to 220? And you can just type in that new number and boom, the width changes. Or what would happen if we were to change this height to 350? You can type in that number and the height changes. And it's even updating the wire length. So if the customer had a very specific wire length that they were going for, we change this back to 185. You can see that number update down there. It's really nice when you can just sit with the customer and kind of have these design review meetings and try to help them meet their target goal for that overall wire length. Of course, we could also get in here in the variable studio and say, what would happen if we changed the wire diameter to 12 millimeters? We see that it increases the wire diameter all over, and it increases the size of the cap here. But we're still going to be holding on to the design requirements of what the inside bend radius is supposed to be. So that's kind of a challenge as well. How can we change the diameter of this wire but maintain these inside bend radii? Well, we're going to show you how to solve this challenge as we go through the tutorial today. Now, this tutorial comes from one of the challenges at TooTallToby.com, and the question that we ask our students is, what is the mass of this part in 000.0 grams? And I'm going to reveal the correct answer to this question at the end of the tutorial. But what you can do right now is you can take a look at this drawing. I'm going to show it to you in full screen, and you can grab a screen capture so you can print out a copy, or you could move it over to your second screen, and that way you can kind of follow along with me in this tutorial, and you can also keep an eye on the drawing with all the required dimensions. So if that all sounds good to you, be sure to hit the like button on this video, and let's get into it with the actual CAD modeling. All right, so let's get into it here. I'm going to move this 2D drawing over to my second screen, and I'm going to launch Onshape here. I am going to create a version of this thing in the public space so that you can search for it. So if you just search the public space for 25-12-08 paper towel holder, then you'll be able to find this document. Maybe if you get stuck while you're following this tutorial, or maybe if you just want a copy of my version of this thing, you can just search for it and you'll have the final version that we finish at the end of this tutorial. The first thing I do whenever I start a new Onshape document is I just go into workspace units and make sure I'm working in the correct units. For today's tutorial, it's going to be millimeters and grams, and you get there right up here from this menu, workspace units. And then the next thing I do is I start a new variable studio. Now, this might seem a little bit weird to right away get into the variable studio, but I think that most of the time when you work with a customer, you kind of know what dimensions are going to be changing. Like in the case of this customer, I think it's fair to say that the most likely dimensions to change would be like the overall width and the overall height. And there may be some other dimensions that will change depending on what I know about the customer, but that's basically where you want to start. You want to say to yourself, what do I think the customer is most likely to change? Let's incorporate them into a variable studio. So the way that we create that variable studio is we go down here next to where it says Part Studio 1, you click on this plus, and then you choose to create a new variable studio. And now what we're going to do is we're going to create variables, and then we're going to assign values to those variables. So what I do is I first kind of go down through this list. This is a table. Variable Studio, it's got a table in it. It's got these columns listed here, and then the rows are going to show up over here as we add more variable names. So this first one I'm going to define as max width, max space width. But unfortunately, I get an error. It shows up with that kind of pink background behind the box. And this is because we can't use spaces in the variable names. So instead of max space width, I'm going to call this max underscore width. And then I'm going to press enter. And then for my next variable name here, I'm going to just call this one depth 2_2_wire. So it's not really the max depth. If you look at the drawing, it's actually the depth here to where this wire might end. But I anticipate that the customer is going to want to know what the overall length of the wire is, because like if the overall length of the wire is 1,015 millimeters, then they're going to want to change the dimension. They might want to change this dimension by -15 so that they can get one full paper towel holder out of 1 meter worth of material. Okay, I'm just hypothesizing here, but I think that's a reasonable assumption in the world of engineering and manufacturing. So I'm going to take this and make another variable dimension here. This one is going to be height _ wire. Okay, so again, this isn't technically the max height. The max height is here to the top of the cap. But I'm going to add in a variable here that's the max height of the wire. This is where the tip of the wire ends. So that one's going to end up being 299. And then I'm going to add another variable here for the wire diameter, wire _ diameter, DIA, enter. And then I'm going to add a final variable here, and I'm going to call this one half _ wire. So maybe you want to just take a moment, maybe pause the video, go through, make sure you've got all those variables listed. And then once you've got those variables listed, we're going to go up here to the column for value. And we're just going to click in this box here, and we're going to type in the values based on the drawing. So these values here are going to be 185, enter. This one's going to be 154, enter. That height is going to be 299, enter. The wire diameter is going to be 8, enter. And now for this final value here, half wire, this one we're going to link to the previous variable, and we're going to do that by typing in hashtag. So shift and the number 3, hashtag, and then you can press up and down here, and you can go down to wire diameter, and you can press enter, and then it's going to be slash, so either on the 10 key or next to the shift key on the main keyboard, /2. So the wire diameter cut in half, the wire diameter over 2. So you press enter, and there you go, 4 millimeters. And then you can test that one by pressing the up arrow to go up to the field that currently says 8. And then you could type in 12 and press enter, and now the half wire updates to 6. Or you could go up there and type in 9, and the half wire updates to 4.5. And then you can put that back to 8, and the half wire updates to 4 millimeters. So if that all makes sense, hit the like button. If you have any questions on what we did so far, let me know down below. But the basic idea is that when you get started with an Onshape project, one of the first things you can do is you can ask yourself, what do I think the customer might change? And especially when those are overall dimensions, overall envelope values, you could consider putting them right into a variable table so you can link dimensions to those values as you're creating the model. And then when you're having a design review meeting with the customer, you can actually bring up this table and quickly make those changes. And the customer is going to think that you are aces because you were able to anticipate those changes. So it's all good. And if that all makes sense to you, like I said, hit the like button, and let's move on to the next section of this tutorial. All right, so now that we've created that variable studio, you can see it's a tab here at the bottom. We've got part studio, variable studio, assembly. We're going to go back to the part studio, and we are now going to create the geometry for this area of the sweep. This area of the sweep is kind of lower area here of the sweep. And then in the next section of the video, we'll create the geometry for this area of the sweep that kind of goes up towards the top of that rod. So to create that geometry for the lower area, I'm going to offset a plane 1/2 wire thickness, because I want to create the center line of the sweep here, not at the floor, but 1/2 wire thickness up. And then I'm going to also create just a quick layout sketch to represent this geometry here. Probably have that layout sketch come over to here, and I'll probably include the center of the rod here as well. So before I actually start creating the sweep geometry, let's create that plane and let's create that layout geometry. So I'm going to start here at this topmost plane, and then I'm going to choose the plane command, and I'm going to choose to offset that plane to a distance of hashtag, and this is going to be 1/2 wire. Enter, enter, and you can press enter one more time to finish that plane. So this is going to be the, I'll press Shift N here. This is going to be plane for lower path. Plane for lower path. I like to rename all my features. Makes it very easy for you to look at the tree and kind of know where you were, especially if you look at these models later on. So that's the plane for the lower path. And how far up is that offset? It's offset 1/2 wire diameter. So if I click over here on this variable table, if I click over here on this variable table and I change the overall wire diameter to 12 millimeters, watch what happens to the plane. It increases in offset because now that variable distance is 6 millimeters. Change this back to 8. And it decreases because now that variable distance is 4 millimeters. So it's good to kind of test out your variables as you're going through the design process. All right, now we're going to create some layout geometry. We're basically going to lay out these magenta lines here just to make it a little bit easier for us to locate the arcs when we come into our second sketch. So we're just going to create some layout geometry here real quick. So we're going to create a new sketch here on this plane for lower path. I don't think we're going to use the tabs too much anymore, so I'm going to bring this back down. Just wanted you to see those tabs when I was creating that variable studio. So click on this plane here, right click, new sketch. You can press the letter N to look at this thing from the top. You could also do Shift 5. That's a shortcut to look at this thing from the top as well. And we're going to create some geometry here. We're going to create a line. Let's just create some geometry that looks like this. A line over, line across like this, a line up like this. Pretty good. Okay, and then let's also create a circle here. Just create a circle here like this. All right, that's it. Everything's loose. Nothing has any relationships. Everything is able to move around. I guess these are technically horizontal and vertical, which is what we want, but there's no other relationships so far. So now what we're going to do is we're going to hit escape and we're going to start adding in some dimensions and adding in some relationships. So we'll take this line here and this point, and we're going to make those coincident. I is the shortcut for coincident, I. And we're going to take this point here and this point here, which is the origin, and we're going to make them vertical. V is vertical. And we're going to take this point here, and we're going to take the origin, and we're going to make those vertical. V is for vertical. And we're going to take this point here and this point here, and we're going to make them horizontal to one another. H is the shortcut for horizontal. All right, so now we can hit escape, make sure we're not in any commands or anything, and now we're going to add some dimensions, and these dimensions are going to be linked to our variables. So a dimension on this line down here, that dimension is going to be, you hold the shift key and you press hashtag, that dimension is going to be equal to the max width. So you press up and down here, okay, max width, enter, enter, boom, there we go. And then we're going to create another dimension here, from here to this line up here. That dimension is going to be shift 3, hashtag. It's going to be linked to the depth of the wire. Okay, the depth of the wire, enter, enter, and that updates. Again, that one's a little bit strange because it's the depth to this kind of corner point here. A little bit strange, but it's okay. Sometimes that's what customers give us. No problem. We can always work with the customers. And then we're going to create a dimension here that goes from this point here, the origin, over to this line. And this one is going to be shift 3, down, 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 max width, enter, and then you're going to type /2. So this is just like when we created the half wire diameter. And that way we have that 92.5 dimension, which we are assuming that that's always supposed to be right down the center. Now, that assumption might be wrong eventually, but I just wanted to use that to show you how to take a variable and then add an operator to it while you're creating these dimensions. So if that makes sense, hit the like button. And if it doesn't make sense, let me know down below in the comments. And then we're going to create a dimension here on the wire. So that dimension is going to be shift 3, and it's going to be up and down here. Find the wire diameter, enter, enter. There we go. And then we're going to create another dimension that goes from this location here at the front of the part to this location for that wire. And that dimension is going to be 73, enter. Now, what we just did there was we just created a layout sketch. We're not actually going to sweep along this sketch, because if you think about it, the way the sweep is going to look is it's going to be like a 1/2 material thickness over this way, and then it's going to come over like so, and then it's going to be 1/2 material thickness away from being tangent, and so on and so on. We have to be constantly thinking about the material thickness. The wire diameter here has to be kind of factored in when we're creating our sweep path. So instead of trying to combine that all together and make one massive complicated sketch, what we're going to do is we're going to finish this sketch. We're going to exit this sketch. We're going to rename this sketch. So Shift N, layout for lower path. Layout for lower path. And then we're going to also right click on that sketch, and we're going to go to edit sketch appearance, and we're going to change that sketch appearance to something that really pops out, like a red or a magenta. I like red. You just have to remember that that red is not an error. So sometimes I'll use like a purple or a magenta instead. So let's use that. We'll go over here to magenta. You can also go to mixer, and sometimes if you go to mixer, you can get that to really pop. You can drag this up here to the corner. So you click here on mixer, and then you drag this up here to the corner, and then it kind of pops a little bit more. So we hit the check mark, and there we go. There is our layout for the lower path. Now, in the next section of the tutorial, we're going to create the actual lower path, but I just wanted to pause here, give you a moment, make sure you've got all these dimensions, you got these linked to the correct variables. So I'll leave this up on screen now just for a moment if you want to pause it. And we are going to now go on to the next section of the video where we create the path for this lower section of the paper towel holder. So like I said, this idea of making a layout sketch, this is something I do pretty regularly. I like to keep my sketches simple, and I'm not afraid to separate one sketch into two sketches if it means it's going to make things much more simple. You know, by making things simple, part of what I mean is now when I go to this plane for lower path, so let's do this now, make a new sketch on that plane for lower path. Now I've got kind of some freedom because I can create dimensions and relations to this purple sketch like tangency, and I know that purple sketch is never going to move. It's never going to get trimmed. It's never going to get deleted. It's kind of like a solid known entity that exists in the background. And that also makes things a little bit easier when you're working with complicated geometry. So now that we are in a new sketch here, we're in a new sketch on this plane for lower path. We don't have any sketch geometry yet. What we're going to do is we're going to create some geometry that kind of looks like this. We're going to just kind of create the geometry of the thing looking down from the top, and then we'll get in there and we'll kind of refine and fully define that geometry afterwards. So we could begin with a line command. We can actually start right here, right at the center of our layout sketch, and make a line that comes vertical a bit. Single click. We can move away. We just like click and then move your mouse away, and then put your mouse over that endpoint and then move away again, and that'll take you into a tangent arc command. So then we can single click again. We can move away from that one. If you move at just the right angle, you can pick up tangency as you're moving away here with the line. So then you can single click, you can move away, put your mouse over the endpoint, come back, touch the endpoint, move away again. That puts you into a tangent arc. It's kind of nice. Okay, and then for this one, you probably want to have this one come around a little bit, you know, a little bit more. Single click, and then you can move your mouse away, come back, touch the endpoint, move away again. Now you're in a tangent arc command again. Single click, okay, move your mouse away, move your mouse back towards it, come around again. Okay, it's okay if you go over this line a little bit. It doesn't have to be all inside, but mine happens to be inside here. Single click, and then again, try to get that tangency there. So now what I do is, to get this sketch to be fully defined, what I do is I use offset geometry. So imagine what we just sketched is a line here like so and an arc here like so. Well, what I'll do is I'll offset this 1/2 wire thickness, so I can make this one tangent to my layout sketch, and I'll offset this 1/2 wire thickness so that I can use that inner arc there to give me that radius 20 for the inside bend dimension. So we're going to do two offsets, one to the inside and one to the outside. So what you can do here is you can right click on this sketch entity and you can say select tangent connected edges, and that goes around and picks the whole thing. And then you can click the offset command here in the sketch. So this is going to offset to a distance either to the inside or the outside. You can choose if you want it to go to the inside or to the outside. So I'll choose, you know, whatever the default is. You can just leave that as the default. It doesn't matter. We're going to do both directions. So you can just left click in the background. And then for the offset distance, what is this going to be? It's going to be shift hashtag, so shift 3, and then up and down here until you get to 1/2 wire. So you pick 1/2 wire there, enter, enter. Yes, that is looking good. And now we can repeat that process. So right click here, you can say select tangent connected edges, and then you can do offset. And now this time we're going to flip this to the other side. So we've got one going to the inside, one going to the outside. And then you left click in the background. And now what's that offset going to be? It's going to be hashtag. And then we go down here to 1/2 wire, enter, enter, and boom, we're done. If you did it correctly, then the diameter should match up here. The offset should match up here. It should match up here to your, your wire diameter from the layout sketch. So it should match up here on either side. So now we are ready to start adding in some relationships in sketch mode. And the first relationship we're going to add in here is going to be between this point and this line up here, and that's going to be coincident. So you press I is for coincident. Now, the thing is, you'll notice here that the other 2 points here didn't line up. So why didn't they line up, or what can we do about that? Well, we can just add another line. So you click the line command, and we can just add another line here. Single click this point. You come over here, you kind of wake up this line, and then that way you can get a perpendicular relationship to that line. Just put your mouse over that line there. Come out here, and now you get a perpendicular to that line. You hit escape. Now, this point and this point, press I, coincident. This point and this point, press I, coincident. Boom, you're good to go. And so now the next relationship that we could add in here could be a relationship of tangent. So you could click on this arc here, and you could click here, and then you could press T, and you can make those tangent. Now, at this point, I might consider jumping from adding relationships to adding dimensions, just to kind of start to lock down some of the geometry in the sketch. So I could click on dimensions, and I could add a dimension here from this line to this line here, make that 35, and then add a dimension here, the inside bend radius. What is that inside bend radius? The inside bend radius there is 20 millimeters. And then I could do the same thing here. Inside bend radius, what is it? It's 110. And then I can do the same thing over here. Inside bend radius, what is it? It's 20 millimeters. And inside bend radius here, what is it? It's 10 millimeters. So a lot of times I'll kind of bounce between adding sketch relationships and adding dimensions in my sketch until I start to really get things locked down. Now, one relationship that's a little bit awkward here, and just it can kind of sneak past you if you're not really paying attention, is that the center of the radius 110 is directly on this center line here. So what that means is we could take the origin and we can make it vertical, or we could use the layout sketch and we could use this point here and we can make that vertical to our center of this 110 dimension. So you can hit escape, you can click on the center of this 110, you could click on maybe this point here at the center of your layout sketch, and then you could choose, whoops, I tried to hit escape there, try that again, this point and this point here, and then you can make those vertical, V, vertical, and that's going to help to align this 110. So now we can hit escape again. We can pick on this arc here, this line from our layout, T for tangent. Oh, look at that. All that stuff went fully defined. That is looking good. And then we can make maybe this arc here and this line here, T for tangent. And then the final thing is going to be just to add a dimension in here. And this dimension is going to be from this line to this angled line here. And that's going to be at 35. And the sketch is almost fully defined. We're still missing one thing here, which is these points need to be horizontal to this point here. So I'm still in the dimension command. Let's hit escape to get out of the dimension command. This point here and this point here, horizontal. This point here and this point here, horizontal. And there we go. So what do you think? Were you able to get that sketch fully defined, fully constrained? If this worked for you, be sure to give yourself a pat on the back. This is not exactly the easiest of geometry, but then what you can do is you can exit that sketch and then you can rename this sketch here. You can say Shift N, and we're going to call this sketch Path for Lower Sweep. Path for Lower Sweep. Okay, and then that is our fully defined sketch there, that path for the lower sweep. And if that all looks good to you, then you are good to go. We're going to move on to the next section of this tutorial. All right, so that was definitely the most complicated sketch that we're going to see in this tutorial. But again, the cool thing about this is that if we go over to the variable studio, we could make some changes here. Like we could change the wire diameter from 8 millimeters to 12 millimeters. And we see that even though the sketch changed, we're still holding our max width here because we're still maintaining that distance to the tangency. And we're still holding the dimensions here for our inside bend radius. And in manufacturing, that's going to be really important. In manufacturing, they don't really really care what the center line of that sweep is. They've got a die that they're going to use to bend that wire, and that die is going to dictate what that inside bend radius is. So when you change that wire diameter from 8 to say 7 millimeters, they might be able to use the same die and they're going to have the same inside bend radius. So it's really important that you're able to hold that. And what's nice about the Variable Studio is along the way, you can kind of test it and make sure that it is working correctly and that everything is updating correctly. But I'm going to change that back to 8 millimeters for our wire diameter. I'm going to close that variable table and I'm going to exit this sketch, because now we're going to create a very easy sketch, which is going to be a sketch on the right plane that represents that transition up to the upper part of this paper towel holder. So I'm going to go to the right plane, begin a new sketch. So right click, begin a new sketch. And I'm just going to sketch a line here. This line is going to start here at the origin, or sorry, at the center of our wire. And it's just going to come out here to this end point. This is the point where it transitions into that curve in the background. And you see that's going through the center of our sketch there. And then I'm going to create a second line, and this second line is going to go right here from that same end point. It's just going to go up vertical like so. Now, what is the height of that line? Well, really, this is going to be a dimension from the floor, from the top plane. So from the floor here, from the top plane up to the tip of that wire, and then that dimension is linked to a variable. Well, something that's pretty cool about Onshape is that when you've got a dimension like that, you can actually click that plane from the tree. So I can come over here to the tree and click top plane, and then I can choose this point here, move over like so, drop in that dimension, and then I can type Shift 3 for hashtag, and this is going to be height of wire 299. Enter, enter, boom, we are done with that. And then the final thing we're going to do with this sketch is we're just going to add in a sketch fillet here. So sketch fillet, and the sketch fillet is going to go between this line, and it gives us a preview there. In my screen, it's previewing at 5 millimeters, very small. And then we're going to left click, and we're going to drop in this radius. Now, what is this radius going to be? Well, on the drawing, it says that the radius is radius 52. Radius 52. But if we think about it again, that's the inside bend radius. So really what this needs to be is it needs to be hashtag half wire plus 52. Because we want to add 1/2 wire thickness to this radius so that our radius is 52, but that it's 52 at the inside bend, even though we're actually drawing the center line of our sweep. So we're going to do this here using our variables again. We're going to come in here to this box. We'll get rid of this 5. We'll get rid of the mm. And so there's nothing in that box there. And we're going to type in hashtag, and we're going to go here to half wire plus 52. Now, this is going to yield an error. So when we press enter here, we see that if we then click in that box, we have this kind of like pink color that's indicating there's an error. And the reason this is erroring is because when you use a modifier that's not like division, when you're using a numeric addition type of a modifier, what Onshape is looking for is a unit system. In other words, it's looking for millimeters, looking for this equation to have millimeters included in the equation. Now, there's a couple ways we could resolve this. Like one way we could resolve it would be to go to the variable table and make this a non-unit number, just make it a generic number without units on it. But what I find to be the easiest way to resolve this is you just go here, you type in the variable name first. So hashtag half wire plus 52, and then you just type space mm, and that's it. That'll resolve it. So if you just do that, if you just go to the end where that number is, type space mm, and you press enter, look at that, the issue is resolved. And like I said, there's more than one way that you can resolve this, but I have found that that's the easiest way to resolve it. You just type space and then type the units, and then boom, you're good to go. So the inside bend radius is supposed to be 52. We're making it 52 plus 1/2 wire. That way, if the wire diameter changes, that inside bend radius will still be 52. And that's going to do it for that sketch. Nice, easy sketch there. We can hit the check mark, and then we can rename that Shift N path for upper sweep. And if that all makes sense to you and you are good to move on, then join me in the next section of this tutorial. So now we have enough information that we could create a sweep. We don't need to create a composite curve to do this. We could actually create a sweep and choose entities from this flat sketch and then choose entities from the sketch that's going up the right side plane, and that would certainly work. I just wanted to show you the composite curve tool so that you'll have one other tool in your toolkit. And basically what the composite curve tool does is it combines selected entities from these two sketches and then just leaves us with a nice, neat sweep path. So to get to this tool, we can go up here to search tools. We can type in COMPOS, and here you can see we've got composite part and composite curve. We're going to choose this one here, composite curve, and then we can go around and pick the entities that we want to be part of this composite curve. So we'll go around and pick these entities from the sketch on the bottom. We'll stop here at this curve. Then we'll pick this kind of shorter segment from the sketch on the right plane. If you can't pick it, you could hide the path for lower sweep. That makes it much easier to pick that entity. We'll pick this entity here as well, that larger fillet, and then this entity here going up to the highest most point. When we hit the green check mark, boom, we are presented with that composite curve. It creates a new part down here in the parts list. So you've got curve 1 down here in the parts list, and we can see that we've got the curve listed here as well. Now, when you are working with a customer that's doing this type of wire bending, a very common question they're going to ask is, can you tell me the total length of the wire? So it's really helpful if you can go and have that number ready to go, ready to share with the customer. And the way that we can do that is we can just measure the composite curve and then include that measurement in a variable. So if you go down here to this field, this button down here, the measure, the little show measure details, then you can right click on an entity in the composite curve and you can say select tangent connected edges. And now here we see that this gives us that total length of that composite curve, and it allows us to add it to our variable table. So we're going to choose to add this to the variable table, and then we're going to give this the name total underscore wire underscore length. And we hit the green check mark. So we're adding all of these, the total wire length here. We hit the green check mark. And now when we go over to our variable table, we can see that that total wire length is listed down here. It's a variable in the part studio. So now when you're sitting with the customer and the customer says, hey, can you increase the height of the wire to 350 millimeters? You say, sure, no problem, Mr. Customer. And then they say, what does that do to the overall length? Well, you can say here, it changed it. Now it's 881 millimeters. They say, oh, that's great. What if we change the width? What if we change the depth of the wire? So this is really cool stuff. And this is something that customers will very much appreciate. You'll really look like a rock star when you can show them how changing these dimensions will affect the overall length of that wire. So now that we've got that, nice, clean sweep path there, here, I'll rename this one. We'll call this one sweep path. Total sweep path, something like that. Now we're ready to actually add in the sweep. And normally what I do when I'm adding in the sweep, what I do is I create a new plane normal to this curve at the end point. And in Onshape, this is very easy to do. All you have to do is pick the curve, pick the endpoint, and then launch the plane command. So I've got the plane command here in my S key menu. So I press the letter S, and then I choose plane. And now look, Onshape automatically creates a new plane perpendicular to that line at the endpoint. And so we hit the check mark, and that plane is going to be our Shift-N plane for profile. Boom. And now on that plane, we can begin a new sketch. So right click that plane, begin a new sketch. And then right here at the end point, you can just sketch a circle. Normally I would do a pierce constraint in a sweep command, but it's such a simple profile, it's just a circle. You can also get away with just dropping it right on the end point. So you drop in that circle right on the end point. Just make sure you actually did get the relationship. So like put your mouse over that point, make sure it's coincident. And then we're going to add a dimension to that circle. And what is this dimension going to be? It's going to be Shift 3, the hashtag there. And we're going to come down here to wire diameter. Wire diameter, enter, enter. Yes, that is looking good. That is exactly what we wanted there. 8 millimeters for that wire diameter. And now we can exit that sketch and we can rename that sketch to sweep profile. So we've got our sweep path here, we've got our sweep profile here, and now we can jump into the sweep command in Onshape, and we can say we want to perform a sweep here, and the sweep is going to be from the faces of our sketch. So you can just choose here inside the circle, and then for our path, you can choose a curve. Now, I've noticed that when I click on sweep path, if I try to choose the curve here, it doesn't work for some reason. So if I choose here, sweep path, nothing happens. But if I go down here to the curve down here in the parts list, Yes, we're in business. So you can just choose it from down there, and that way it gets the entire curve. And this thing is looking good. I'm liking it. So hit the check mark. And then as always, I just think it's always a good idea to kind of test your variable studio a little bit. So you come over here, you change this to a diameter of 12, sweep updates. That looks good. Change it back to 8. The sweep updates there. You'll notice here your wire length updates as well, because it's kind of changing where the centers of your sweep path are. So if you notice here, if I change this to like 10 millimeters, it actually updates the wire length as well. I think that's pretty cool too. Change that back to 8. Let's change our total height here, 350. Yes, that works. Back to 299. And then our total width here, let's change that to 210. Oh yeah, that works as well. And then we'll change that back to 185. Sweet, this thing is working good. I like it, I like it. So that's gonna do it for that section of the tutorial. In the final section of the tutorial, we're gonna add in this little notch up top here, and we're going to add the cap up top as well. But let me know down below in the comments, do you have any questions? Do you like what you see so far? And if you do like what you see so far, be sure to subscribe and be sure to like, and I will see you in the next part of this tutorial. All right, so we're coming down the home stretch here. I think we're probably done with our layout for the path. I don't think we need to see that. We could probably hide some of these planes as well, hide some of these planes that we were using to create this geometry. And I think we're pretty much ready to now add that little stepped area at the top. So you can see here, we've got this stepped area, 5 millimeter diameter, 13.5 deep. So to create this geometry, it's just gonna be a simple cut. One thing you wanna remember is that you can do this by just creating a new sketch up here on this face, and then sketching a circle with a diameter of 5 millimeters, and that's it. After you have that diameter circle created, you can hit escape, and then you can just click here in this region, and now you can jump into extrude, and you can see that you can create an extrude here that goes to that depth of 13.5, and this is going to be a remove. So because we kind of clicked in this region first, Onshape picks up on that region as a closed region to do our cut. I think that's so cool and so easy to do. So we've got our sweep here. This would be our main wire sweep. And now we've got this new sketch. This will be sketch for step. And then this one will be cut top wire step. Now let's create the revolved shape that goes on that top wire step. So for that revolved shape, what we're going to do is we're going to focus in here on this view. And we can see that what we're trying to do is we're trying to create some relationships to that stepped area that we just created. You can see that we're creating a relationship here for this 8 millimeter long line. That should kind of be right in line with the sidewall of that wire. We're creating a relationship here at the top of the wire for that 2 millimeter gap. We're creating a relationship here where there's no gap. So we're creating these relationships to the top of that wire in that area where we just created that step. How do we create those relationships? Well, something pretty cool that we can do in Onshape is we can capture where our sketch plane is intersecting with these faces, and we can turn that geometry into sketch geometry. And the way that we do that is we start a new sketch on a plane. Like in this case, I'm going to start a new sketch here on the right plane. So imagine the right plane is running through there. And then we use a command called intersection in our sketching tools. So let's start out here by beginning a new sketch on the right plane. Here you can see what the right plane looks like. Maybe I'll bring this up here so you can kind of see how it's going right through the middle of that stepped area. So I'm going to start a new sketch here on the right plane, new sketch. And then once I start that new sketch on the right plane, what I'm going to do is I'm going to grab this face and this face and this face and this face. I'm just left clicking on those faces. And then I'm going to tell Onshape to decipher wherever the right plane is running through those faces. And I'm going to do that using this command here. It's underneath the use project command, and it's called intersection. So as soon as I click on that command, look at that. Onshape goes in and it adds in that sketch geometry. And that's so helpful because now I can reference that sketch geometry when I'm creating the geometry for this lid. So for example, to create this 8 millimeter section that goes up here, 8 millimeters straight, and then create this 40 millimeter section, 40 millimeter radius, and then this 1 millimeter section, and then this flat spot here. Well, what I could do is I could get to a normal view, press N, rotate this thing normal. Now I can get into the line command and I can just single click here and move up. And this is going to come up to 8 millimeters. Then I can move my mouse away, come back, touch the end point. Now I can come off of here with a radius of 40. So single click, type in that dimension. Now I can come back, touch this end point, come off and around. This one's going to have a radius of 1. single click, and then I can come across here with a horizontal line and I can just hit escape. Now for that horizontal line, what I'm going to do is I'm going to pick this line and this arc, and I'm going to make sure that those are tangent, and then I'm going to make sure that the line itself is horizontal, so H for horizontal. So I think I got tangent at first, but I didn't have horizontal. Usually it's the other way around. And now I just need to add in a dimension here. So a dimension from this point here up to this line, and that dimension is going to be at 30 millimeters. And so that's how you can really take advantage of that intersect command. I was able to use intersect to generate this line here and generate this line here, and then use that to get started with this cap. But it doesn't stop there. Let's go back to a normal view here, and then let's use the line command and create a line that comes up from this point. So this is going to come up like so, and I'm going to hit escape, and that line's going to be construction. So I press Q. So see, I'm picking up on that midpoint relationship there, and then I'm going to add a dimension that goes from this point to that line, and that dimension is going to be 14 millimeters. And now I'm going to create this shape here, which is called out as a spherical cut here running down through here. So whenever you have a spherical cut, what that means is that the radius here stops at the center line that you revolve about, or the radius has a center point at the center line that you revolve about. So what that means is that when I go to create this geometry here, I can create an arc, and that arc's going to come down like so, just going to come right here to the center line that I created. And then I'm going to hit escape. And then this point of that arc, the center point of that arc, is going to be coincident to this line here. So we press I, make that coincident. Now we can add a dimension. The dimension is going to go from this line down to this point here, and that dimension is going to be 2 millimeters. And then we can finish this thing off by just adding in some additional geometry, a line that comes down here, not all the way down, right? There's a gap, so almost all the way down, and a line that comes over. It doesn't match up perfectly, but there's a slight gap again, and then this line comes down like so. So we can hit escape, and now once again, using that intersected geometry, we create a dimension from this line to here. That's going to be a gap of 2 millimeters, and a dimension from this line to this line here, that's going to be a gap of 0.4 millimeters. So that should give us a real nice press fit there. And then we can hit escape, and then this point's just going to come all the way down to this other line that we use the intersect for. So that intersect command is super, super helpful in Onshape, and it really helps you when you're designing two parts that are meant to function together, that are meant to fit together. Use that intersect command a lot. I use it all the time. So now we're ready to go into a revolve command. We do have a nice closed region here, so Onshape automatically picks up on that closed region, and all we have to do is pick on the revolve axis right here. And the thing is, if we revolve this right now, Onshape defaults to use an add function, and the reason for that is because this area here is right on top. There's no gap between these two edges, but we want this to be a new part. So we click new here, and that creates a new part studio down here. Now we have part 1 and part 2 down here, and that's what we want. So make sure you choose new there, and that should give you the geometry for that cap. And this thing is looking pretty good. Again, as always, what I like to do is I like to come over here and just kind of test my variable studio. So we'll change that to 12, and look at that. The cap updates right along with that change. Change it back to 8, and we're back to our correct values here in the variable studio. So we're pretty much done with this thing. I think the next section of the video is going to be the conclusion. I'm also going to tell you what the correct answer is here. We do need to assign the correct material density, so we'll do that in the next video as well. And then we will reveal what is the correct answer. What is the mass of this multi-body part or assembly? I'm looking for the question mark symbol. Here we go. What is the mass of this multi-body part or assembly in xxx.x grams? So we will reveal that in the conclusion video as well. All right, well, congratulations. I think we're pretty much at the end of this video tutorial. We got to cover a lot of different tips and tricks and advanced techniques in Onshape, and I hope that you found this useful. But let's bring this thing across the finish line proper. So normally what I do here at this point is I press the letter P on my keyboard. P is going to hide all of my reference planes and sketches and things like that, or Shift P will actually hide everything. P will just hide my planes. Shift P will kind of hide everything. And then what I do is I come over here to the tree. I make sure that everything has been renamed. So this could be called sketch for plastic cap. And then this could be called revolve, Shift N there, plastic cap. And then down here in the parts list, I'll rename this. I'll rename this one here to main bent rod. And then I'll also rename this one here, part 2. I'll rename that one to Shift N plastic cap. And there we go. And then just something I like to do when I'm working with customers is I like to right mouse button on each of these parts and go to edit appearance and just kind of make the appearance match what the customer gave me. So I'll change the rod to be more of like a gray color, and then I'll change the plastic cap here to be more of an orange color, like this orange brown color here. So now that we've got those two in place, now that those two are looking good, now we are ready to assign the correct material or material density. Now we have a website, TooTallToby.com, and on that website, there's a TooTallToby.com/materials where we talk about all these materials and how to set up these materials in Onshape so that you can have the correct material density. But if you're just doing this as a tutorial and you don't want to set that up, you can always go to your components and change their density. So I could right mouse button on this part here, the main bent rod, and I can say assign material. And then here I can just say that I want to use a custom material, which lets me put in a custom material density. So I could just call this something like steel, and then the material density here is going to be 7.8 grams per cubic centimeter, which should give us 7,800 kilograms per cubic meter. You could also change that unit system here. If you go in here to the hamburger menu and say workspace units, you could change this to kilograms per cubic meter. And that way, when you're looking at your edit material, you can make sure that that's set to 7,800. And then for the plastic cap, we can do the same thing. We can say edit or assign material, and we can make this one custom. We could call this plastic just as a one-off, and then we could change this density here to 1020 kilograms per cubic meter. And so we hit the green check mark, and there we go. And if we did this correct, the correct answer here, the correct material, or the correct answer to this question of what is the mass should be 324.9 grams. That is the correct answer. If you're going through and you're modeling this up and you want to see if you got it correct, the correct answer here is 324.9 grams. And so if we go back here to our model and we say we want to measure the mass of our model, it's down here in the corner, this display mass properties, and then we click on each of the parts here from our parts studio, we are coming up with an answer of 324.9, and that is correct. And so we did manage to model everything up and do it correct. So good job to us. But more importantly, when you're working with a customer, if you take advantage of this variable studio and you kind of take your time to set things up and you think a little bit about the manufacturing process, like the idea of the inside bend radius and the idea of setting this thing up so that it's got an overall width and an overall depth there, because that's probably what the customer is going to be looking at. Well, then when you're doing your design review meeting with the customer, you can start making changes. The customer might say, what would this look like if it was 215 wide? What would it look like if we move this wire back just a little bit further? If we make that like 170, if we move it back, what's this going to do to our overall total wire length? You know, these are the kinds of questions that your customer is going to ask during a design review meeting. And so having these set up ahead of time in your variable studio is really going to help you look like a superstar. So if you enjoyed this tutorial, be sure to let me know down below in the comments. Be sure to hit the subscribe button. Be sure to come back for more great Onshape step-by-step tutorials. And let me know if you have any questions as well. If you have any suggestions or any questions, or if you want to see anything more from this tutorial, or if there's anything you want to see in future tutorials, let us know that down below in the comments. We read all the comments. We try to respond to all the comments. And I look forward to seeing all of you in the next TooTallToby Onshape tutorial. See you, everybody.